Yeah. If you look at the unit circle, you have the values for cosine and sine. You could add the values for tangent, okay? And you also see the values of the angles on the unit circle. You know, pi over 6, pi over 4, pi over 3, and so forth. We'll change our perspective now. Let's say I just focus on cosine. What value does cosine start out with? 1. When you're doing cosine of 0 degrees or 0 radians, the answer is 1, right? At pi over 6, cosine gets smaller, and then smaller, and smaller. Then they get 0 here. And then if you keep tracking the value, it's going to get smaller and smaller, so it bottoms out at a minimum of negative 1. Again, it's bigger, bigger. It's 0 here at 3 pi over 2, and then it hits a maximum again here. Okay? That's what we're going to do here. So once again, on the sheet that's blank on one side, find the cosine graph. We're going to fill this in. Yours doesn't look exact like that, but it's close enough. Yours is marked going up to positive 1, down to negative 1, right? And then all you have is the quadrant angles, which is all you really need. This has more marks than we need. So, how do cosine start again? 1 or 0? And look, if you ever forget, just draw that part of the unit circle. We're talking about cosine, so it's x value. So yeah, 1. So at 0 degrees, 0 radians, put a point at 1. And then if you keep going around the circle, cosine's next 0. So at pi over 2, put a value of 0. And then it's negative 1. And then cosine 0 again. And then it hits the maximum of 1 again when you get all the way around the circle. Now, before you connect those, listen. This thing is a periodic function. If you kept going, it would repeat the same pattern, okay? And so the point is, if you drew it like this, watch. If you drew, like this is going to curve here, but then what people do is they aim for this point like so. If you draw like that, that's a fail, because it doesn't keep going. It's going to curve back down for the next iteration, the next cycle. So here, watch. Basically, what you want to do is either, if you're starting at this point, kind of go horizontally and then curve down, or if you're going towards the point, aim for like here, and then get curved towards it as you get closer. Go ahead and draw it now. And so far, we've drawn one cycle of the cosine function. We're going to draw more than that. This thing goes on forever, though. So can anyone tell me the domain right now? All real numbers. So either write negative infinity, positive infinity for the domain, or put the symbol, some funny looking R. What's the range? Negative 1 to positive 1, inclusive. Okay? I'll get back to the other questions. Let's go ahead and finish the graph. We're going to go from negative 2 pi to positive 2 pi. Before we continue, look, like this part of the graph right here, that corresponds to the first quadrant. You see that? And then this from pi over 2 to pi represents, so the 0 to pi over 2 is first quadrant, then pi over 2 to pi is second quadrant, then third quadrant. And so this third quadrant, fourth quadrant, then it'd be first, second, third, fourth, first, second, third, fourth. You're just going through the quadrants, one after another. Which means, what quadrant is here? If you go backwards from the first quadrant, you're passing backwards to the fourth quadrant. You'll go fourth, third, second, first, fourth, third, second, first. If you go backwards, yes? So, look, it's like we're over here, and we're backing up to the fourth quadrant, so it's going to go down to here. And then you're going through the third quadrant, backwards. You went from an x value 0 to an x value negative 1. Or if you look at the graph, it just went from here to here, then it's going to go up again, because the same pattern repeats itself. Then it hits the maximum again at negative 2 pi. So how far do we have to go before it repeats itself? 2 pi. Just look up here. When I say the period of function, it's basically a number you could add on to an x value, so your function value ends up being the same. And so if you add 2 pi repeatedly, you get the same value over and over and over again. It's periodic. The period is 2 pi. So put that for the period, 2 pi. And listen, all the trig functions have a period of 2 pi. I just want to emphasize, some of them have a smaller fundamental period, like you could write it less than 2 pi, but certainly every 2 pi, they all repeat, right? Some of them, like cosine and sine, that is the smallest period. The period of sine is 2 pi. The period of cosine is 2 pi. For tangent, it would be actually a smaller number, all right? Now, one more thing, amplitude. Yes. When I say amplitude, it's a term that applies only to waves, and it's that distance there, from the middle to the top, or from the middle to the bottom. In this case, yeah, from the midline up to the top of the crest to the bottom of the trough. And for sine and cosine, the amplitude is 1. Okay? So it's not the total height of the wave. So I called what it's the x-axis here, I called it the midline, but it's also known as the axis of the wave. So a cosine graph is oscillating from one above the midline to one below the midline, up and down, over and over again. Okay? Let's do sine. How does sine start? We're talking about y values now, so it starts at the origin. And at pi over 2, your y value is 1, so go up to 1. And listen, seriously, with sine, people mess up. They go down instead of going up like they should. It's easy, though. This is the first quadrant. Everything in the first quadrant is positive, right? So it must go up to positive 1 in the first quadrant. And then it's going to go back down to 0. The y value is 0 at pi. And then down to negative 1. The y value is negative 1 when you're at 3 pi over 2. And back to 0. And there you go. There's one cycle of the sine function. But notice here, like when you get close to this is the middle of the graph. It doesn't curve there. It's going to cut straight through there because you're not at the bottom of the top at that point. Main range are the same. The period is the same. It takes 2 pi to complete a cycle. The amplitude is the same. In fact, the shape of the graph is the same. Sine and cosine are the exact same graph, just shifted over. Together, they're known as sinusoidal waves, sinusoidal curves. Both sine and cosine are the same shape. That's the term for them, okay? And one thing I want you to understand is sound waves are modeled by, and the amplitude, if you increase or decrease the amplitude, that decreases the volume or increases the volume of the sound. If you change the period, that also affects like the frequency of the sound, or basically the pitch, how high or low the sounds. Okay? And so anyway, now we need to draw the rest of this. And let me just say this. The directions are going to vary depending on what we're doing. This one, I want to draw from negative 2 pi to 2 pi on the whole sheet, okay? Then other times they'll say, I'll just draw one cycle of the function. Or maybe they'll say, draw from 0 to 2 pi. I'm just saying, read the directions, follow the directions. Here, I'm going backwards now, is to the fourth quadrant. Here in the fourth quadrant, from 0 down to negative 1, so do the same thing here. You're going through that same pattern again, backwards. So you get down to negative 1, up to y value 0, up to 1, and back down to 0. We're done. One more thing I want to show you when we're talking about period is like, watch this. If I go from this peak to this peak, or that crest to that crest, that's from like negative 3 halves to positive 1 half. It's like 4 halves, but 4 halves is 2 pi, isn't it? If I were to go, let me go back to the cosine graph. If I was to go, let's see, from this, no, I'll go from this point here. From this trough to the trough of the next wave. That's from negative pi to pi. That's also 2 pi. So the point is, you pick any point in the graph, and you go 2 pi, then you basically start over on the graph. You have the same function value. So from negative 2 pi to 0 is 2 pi, and it hits the peak again. And every 2 pi is going to hit the same point again. Okay? All right. Now we start talking about transformations. Now you have this on your paper already. It's like in the top left corner, right? Which represents vertical changes? A, B, C, D. Which of those are vertical changes? A and D. If it's outside, you're supposed to know it's vertical. Inside is horizontal, right? That's what I'm saying. You've done it before. It's the same transformations functions, just with new parent functions. Okay? And a little bit of new terminology because we're talking about waves, so they have amplitude and period. One thing I want you to notice right here, if you ever combine a horizontal stretch or shift with stretch with a shift, you need to put it in this notation. Now, let me get a couple things straight. If it's inside, you do the opposite. So if you saw like x plus pi, that's actually like, you treat it like minus. You go left. And if you had like 2 here, well, you're actually doing the opposite. And opposite doubling is taking half of. And so, now, here's the deal. If it is something like this is not a shift left pi. You want to rewrite it in factor form. Okay, it's supposed to be pi. So you interpret it correctly. So that's why it looks like this. If you combine, a stretch or shift, horizontal stretch or shift, stretch or compression, sorry, with a shift, you want to write it like this. Most of the time we don't have them combined, but if we do, you write it in factor form. All right, we'll start with this. This is easy. This is a vertical stretch, yes. In fact, we'll write that up. Vertical expansion by a factor of 2. Yeah, we're on the other sheet now. And find it, number 1 on the other sheet. Like I said, if I ask you to list the transformation, you need to be specific. Don't just, I said expansion. Anything that's synonymous is fine. Vertical stretch, that's fine. Okay. Now that means nothing horizontal has changed. So put your normal numbers there. Your quadrantal angles: pi over 2 pi, 3 pi over 2, 2 pi. Now, you don't have to label the 0. It's just the origin, but I want you to realize there's really 5 marks that we use. It's our starting point and the 4 marks after it, because that corresponds to 4 quadrants. The gaps, these 4 gaps corresponds to the 4 quadrants, okay? Now, those always have to be labeled, all of them. Start with a 0 in this case. Vertically, if you're going up to 2, here's what I'm saying is, if you just want to put a mark up there and call it 2, that's fine. If you put 2 marks, I'm okay with that too. I don't care. But you must label it. You must. So if you just had the 2 marks here and you didn't have them labeled, then I don't know what your scale is. I'm not assuming. It's going to be kind of wrong. Okay, so like here, put the 2 there. I know you're going by ones. It's fine. And then we're going to go down here to -2. And just draw your sine graph. It starts at the origin like normal. Sine of 0 is 0, right? And then instead of going up to 1, it's vertical expansion, so it goes up to 2. And then it's going to go back to 0. Because 0 doubled is still 0. And then instead of going down to -1, it goes down to a minimum of -2. So it's easy. We hit a maximum of 2 and a minimum of -2, right? The axis of the wave was the x-axis, y equals 0. If it asks for that, I don't know if it does here, but the axis is that line y equals 0, or the x-axis. And the amplitude, of course, is 2. All right. Next. Is everybody ready? All right. And I'm trying to go kind of quickly through these because they're, frankly, relatively easy. Just vertical compression. Same idea, you're just compressing. As far as showing it, look, as long as you have them marked, your top marks labeled 1/2, we're good. I want to kind of scale it compared to the last example. It should be much smaller than the last graph, right? So I'm going to try to draw it smaller. I'm just saying, as long as you have your max labeled as 1/2, your min labeled as -1/2, the rest is unnecessary. And then just draw your sine graph. Start at 0, go up to a max of 1/2 this time, back to the minimal, down to a minimum of -1/2. And we're done with that one. And of course the amplitude is 1/2. Here the amplitude matches the max simply because we didn't shift up or down. And so as soon as we do that, you'll see. In fact, let's think of this. What if the whole thing was shifted up 2? Then the middle's at 2. Where's the max? A half unit above that. And then the minimum will be a half unit below the middle. And so no, the max and min will vary. They won't always match. It's a good question. All right, another one. This one, what kind of flip is that? Vertical or horizontal? It's outside, yeah, so it's vertical. Which means the horizontal numbers are just normal. Put those there. And it's still going to have an amplitude of 1. If I write that down, the amplitude is positive 1. Amplitude is always positive. It's just that it's oscillating down first instead of up. So let's say it start at the middle, go down to -1 instead of up, like normal. But then go through your pattern. Go back to the middle, back up to the top. Like I said, this should look upside down to you because normally you'd go up to the positives in the Jewish question. So it's abnormal for it to be having negative y values at the beginning. Okay? Okay, we're going to skip to number 5. We need more time with this one? Okay. This one is just a vertical flip and a vertical stretch by factor 3. Just tell me though, what would the amplitude be if we did this one? The amplitude is just 3. Yeah, it's going to oscillate 3 above and below still. It's just starting by going down instead of up. All right, we will do this one. First of all, I need you to understand that what you're looking at is the same as it's sine of x plus 1. Add the parentheses there. Make it clear this is not sine of x plus 1. Parentheses don't go around the whole thing. That'd be a horizontal shift. That's not what we're doing right now. Okay? And seriously, look, if you do sine of like 3x, then you're doing sine of the whole thing. It's not just sine of 3 times x, it's sine of 3x. So if you have a monomial, something times x, then you're doing sine of the whole thing. But if you want to do sine of a binomial, then the parentheses have to be around the whole thing. Otherwise, the one is separate. This is a vertical shift, in other words. Okay, in fact, write that down. The plus 1 means it shifts up 1. So it's easy. I'm just saying, be careful that you don't misunderstand the notation. All right, since it's vertical, once again, normal numbers go on the x-axis. And the whole thing shifts up 1. So your axis is now shifted up 1. When it says AOW, that's the axis of the wave. The equation is now y equals 1 instead of y equals 0. Where's the max? Yeah. You're just going 1 above the minimum, above the middle, and 1 below will hit a minimum of 0. And then draw a sine graph. One thing, listen, when you start, when we talk about transformations of functions, when we do shifts, I like to shift the origin. In other words, we shifted up 1, so I would draw a nice strong plus sign there, indicating that's your new origin. That really helps because we're doing sine right now. Sine starts at the origin, so sine will start at that point. But if you're doing cosine, cosine starts above it. So where did cosine start? Cosine would start up here. Okay? And so it just helps to orient you if you just make that your new origin. Now draw. Yeah. You can do that. I mean, just like plug in these numbers.
Yeah, so like, when you have 0, 1, and then 1, then you just so like, you can gear shift down,
Right. I mean, but that's true. Look, if I follow correctly, if I go back to the parent function, your numbers were 1, 0, -1. We're just increasing all those by 1. Is that what you're saying? That's exactly right. Yeah, sure. Here, let's just finish this. So, yeah, the whole thing is just shifted up 1. I normally like shift the starting point and then just draw the curve from there. And you're basically saying just take the original graph and shift every point up one, and there you go. We're not going to do number 6, the one that's on your paper. We're going to skip it for now. So look at number 7. This is a horizontal shift. Which way? Left or right? You do the opposite, so it's right pi over 2. You see a minus, you think that takes you left, but once again, it's the opposite. Okay? So this one's easy. Just move your starting point right pi over 2. And like I said, I would make that a nice big plus sign. That's your new origin. So we need that starting point. We also need 4 marks after that. So we have 4 gaps, which means 2 pi is not far enough. We need to go 1 mark beyond that. You're just going by halves, right? So it's like 1 pi, 1/2 pi, 2 pi, 2.5. But you'd write 2.5 as 5 halves. Vertically, nothing's changed, so just using your normal numbers there. And then draw your sine graph, but starting here. So there's your new origin, so start at 0 there, and then go up to 1 like normal, back down to 0. And connect the dots. Now listen, all we're drawing is 1 cycle of the function here. The reality is, if you wanted to go backwards, like here, if I went back from that, what I consider my starting point here, it would hit the y-axis there, wouldn't it? You could draw, like you could start all the way over here if you really wanted to. So what I'm saying is, if it requires you to draw 1 cycle of the function, any cycle of the function that's correct, get you credit. So if you drew from here to here, well, that's correct, generally. Now, I'm normally just going to do the easiest thing, which means I'll start at pi over 2 and draw the right after that. Now, it asks for the zeros. Okay, 0 of a function, like I'm going to write this down. The 0 of a function is an x value that makes the y value 0 or the function value 0. So what are the function value? I mean, what are the zeros of this function? Well, pi over 2 is the first 0. It's the first x value that makes the y value 0. What's the next one? Yeah. And then pi over 2. If they're real zeros like these, they basically correspond to the x-intercepts. So those basically your x-intercepts. If it asks for the y-intercept, I erased it, but wasn't the y-intercept -1? So they could ask that kind of question too. It shouldn't be hard. You know how to draw the graph. You try the next one. Oh, yours has a plus sign there, right? Actually, you try this one. All right, I need you to go back to, where'd it go? Number 6. We're going to change number 6. Make it look like this. Frankly, everything so far has been too easy. We do something a little harder. That's shift left, right? Correct. So now it's not automatic. You have to really think it through. To help figure out exactly what your number should be, we're going to write the math down this time. On the last ones, it was easy. If you're shifting left pi, you just move left 2 marks and call it negative pi, and it's easy. So I'm saying change number 6. Yeah, make number 6 look like this. And then somewhere where you have room, you're going to do your normal numbers. Now, what would this transformation do to your x values? Well, we said the opposite of what you see. You're shifting left pi over 6, which reduces your x values by pi over 6, yes? So do that. But what we would normally put there and subtract pi over 6 from all of them. I'll do the easier ones first. 0 minus pi over 6 is just negative pi over 6. And that's kind of obvious that you'd be starting at negative pi over 6, but it's good to write it down. 1 minus 6 is 5/6. There's that one. 2 is 12/6. So 12/6 minus 6 is 11 pi over 6. Let's go back and do this one. A half is 3/6, yes? Well, 3 minus 1 is 2/6. But that's the third. 2 over 6 is the third. So pi over 3 goes there. And then 3 halves equals how many sixths? 9. 9 minus 1 is 8/6. Divide by 2, yeah, 4 pi over 3. So that's our numbers. Listen, all you have to have labeled in your graph is these 4, these 5 actually. But, and before we draw this, what is the spacing between these numbers? Half still. Look, all it is, take these, which are half apart, we reduce them all by the same amount, they're still a half apart. You should realize that, okay? What I'm saying then is on your graph, there should be equal spacing between those numbers. But tell me this, is this mark the same to the left of the origin as this mark is to the right of the origin? No, this is twice as big as that, isn't it? How far apart are these? A half. How far are these? A half. If you mathematically add a half to that, you get this. Add a half, you get this. Add a half, you get this, and so forth. So I'm saying as far as spacing, the smallest gap is the 1/6 you'll have right here. So draw it kind of small there. What I want you to focus on right now is getting equal spacing from this mark to the next mark. Put it like, let's say right here. Actually, this, we said this should be twice as big as this, didn't we? So draw it roughly twice as big. I want this to be as close to being, to scale as possible. And then that gap from that mark to that mark should be the same mark, the same gap you put to the next. The next number was 5 pi over 6. The next mark is 4 pi over 3. And you just have to go. And the last mark was 11 pi over 6. But hopefully you see what I'm saying. The spacing between these marks should be equal. They should all be pi over 2 in this case. And so what I see people do is they make the gap from here match like this. They'll put negative pi over 6 way over here. I'll try to draw it to scale. Now, the only shift was the shift left pi over 6, yes? So what I'm saying is this is our new origin. We just shifted left pi over 6. Vertically, there's nothing going on. We're not shifting up or down. So now just draw it. It's sine, so we start here. At the next mark, it goes up to the positive 1. What's the y-intercept of this graph? I don't know. But it's not 0 and it's not 1, is it? So I'm saying be careful of that. People really, really want to hit the 1 there, but it doesn't. Over at pi over 3, it's up to 1. And then the next mark is down to 0. And it's down to negative 1, back to 0. It's a normal sine graph, just kind of unfamiliar numbers. Okay? Ready? Let's do this one next. How do you describe that transformation? Is horizontal what? Compression or expansion? You do the opposite. The opposite of doubling is taking half of, so it's actually compression. But don't you have that one? No, it's the same thing. But you can put the parentheses. They're not necessary. It means sine of 2x whether the parentheses are there or not. That's what I was trying to say before. If it's a monomial, then you're doing sine of the whole thing. If it had been sine of like x plus 2, then that parentheses have to be there for the 2 to be part of it. If you leave the parentheses off, then the 2 is separate here. But here, the parentheses don't matter. Either way, you're doing sine of 2x. It's a horizontal compression by a factor of 1/2 because you do the opposite. Okay? That's supposed to be times. Which means our horizontal number is going to change. Now, we're basically just going to take half of our normal numbers. So I'm going to write that down again. And I'll write down all our normal numbers. I'm taking half of 0, half of pi over 2, half of pi. I shouldn't use an x for a time sign. It's a bad idea. And then half of 2 pi. And listen, this isn't too bad, so maybe you could get this done without writing it down. But I'm saying if you're not sure, write it down. And actually what I'm going to do is, look, it's going to end up at pi, right? Just to show kind of the transformation, I want to leave room for another cycle here, okay? But here, if that's pi, then this is pi over 2. This is the pi over, well, okay, I didn't write these down. Starts at 0, half of 0 is still 0. This is pi over 4. Then this is half pi, obviously. Which you could have figured this out. Half of a half is a fourth. And then this works out to 3/4. But like I said, you could have figured out, you're going by fourths, so it's 1/4, 2/4, 3/4, 4/4. That's not too bad. And then vertically it's normal. So there you go. Draw your function. Start at 0. It's going through the function twice as fast as normal. Which means by the time you get to pi, it's done with one cycle of the function. And so what is the period? Pi. And that's really easy. Listen. Apply the transformation to the normal period. What's the normal period for 2 pi? So that's why it's pi. You compress by a factor 1/2, so of course it's half of that. Okay? And just watch. If I went all the way to 2 pi, it'd complete one more cycle by the time we got to 2 pi. All right, where are we at? No, we're doing good. Okay, this one, you ready? This is a little weirder, to say the least. And I want you to change yours. Change your number 10 to match mine. I inherited these notes from someone, and I decided that they're probably L-level notes, frankly, initially. Okay. You're going to, look, the opposite of multiplying by 2/3 is dividing by 2/3, but dividing by 2/3 is the same as multiplying by the reciprocal? I think it was, okay. It's an expansion, in other words. You're multiplying by 3/2. The reality is you're multiplying by 3/2, which makes it an expansion. So it's easy to just think of reciprocals. The opposite of multiplying by 2/3 is multiplying by 3/2. So let's do the same thing. Let's take our normal numbers times 3/2. I'm not going to do 0. That's easy. Pi over 2 times 3/2 is 3 pi over 4. The next number is pi times 3/2 is 3 pi over 2. What's 3 pi over 2 times 3/2? And then finally 2 pi times 3 pi over 2. Oh, no, times 3 over 2 is just, 3 pi. Before you start putting those in your graph, there should be a nice pattern to these, okay? If you talk about force, because most of them force, this 3/2 equals how many force? 6 force, okay? And this equals how many force? 12, so it goes 3 force, 6 force, 9 force, 12 force, okay? It's going by 3 force at a time. And let's do one more thing. The period. The period of our graph will be 3/2 times the normal period, which is 3 pi. All right, I'm just going to put these marks, I'm going to put 4 marks after the origin, and just label them with those numbers. 3 pi over 4, 3 pi over 2, 9 pi over 4, 3 pi. And we draw our function. Once again, there's no shifting going on, so you start at the origin. And then just up to 1, down to 0, down to -1, down to back up to 0. Okay. Horizontally, we're shifting left to pi over 2. So just, we'll do this quickly. Put a mark at negative pi over 2, and then make that, a good, strong plus sign for your new origin. And then there's nothing else horizontally, so your period is normal. You're going over pi over 2 from mark to mark. Once again, I need 4 marks after that, so I need to go to 3 pi over 2. So that's all you need to change horizontally. The vertical flip, we don't need to worry about that yet. Okay, that just changed how we draw the graph. The shift up one, we do need to put on here. So shift up 1, that's your new axis. Now we draw the new axis. Okay, I messed up. Because my new origin is not here. It's up there, yeah. Sorry. So we shifted left pi over 2 and up 1, didn't we? Sorry about that. Now just be careful, because once you draw that, usually drawing the graph part's almost automatic. Just don't forget there's a vertical flip. So from the middle, don't go up, go down instead, to the bottom. And so it's a normal graph, except it's upside down. We are just going to do your last combo. That'll suffice. I can show you the other one some other time. And I don't have it. It's just 1/3. Where are we at time-wise? That's just easy. I'm sorry. Let's go for it. Write this down. On the last combo, write that down. And change it to this. I know I'm being wishy-washy. I apologize. And frankly, the horizontal part's the part I really want to talk about. Okay? It combines a horizontal compression with a shift. What goes here? You take 1/4 of everything. Like, I'm factoring out a 4. Yeah. So basically, I divided both parts by 4 to find out, what remains after taking the 4 out. So you can think you're dividing by 4, you're taking the 4th up. It's easy to think of taking the 4th up because then you just multiply 4th times a half. Okay, that wasn't pretty. Now, let's try this a little different way. We're going to definitely start at pi over 8. Let's write pi over 8. Sorry. Oh, wait, it's plus. I'm sorry. I was right that it's left. I just messed myself up. All right. How much are we going to go over? Let's try a different tack. How much are we going to go over every time? Like, let's put it this way. The period is going to be 1/4 of 2 pi, isn't it? So, pi over 2. That'd be the whole period. That's how long it takes to go from beginning to end. And then how much is the gap between? Well, it's also 1/4, because taking 1/4 of everything. That's GAP. So a fourth, and normally it's pi over 2, so it's pi over 8. That's like the spacing between our numbers on the x-axis. Well, that means, in fact, I can actually scoot this over a little more. Just go over an eighth, you hit 0. Go over another 8, you hit 1/8. Go another 8, that's 2/8. That's a fourth. Another 8, 3/8. That's 1, 2, 3, 4. I'm good. How far is it from the beginning to the end? From negative 1/8 to 3/8 is 4/8, which is a period of 1/2. Okay. The whole thing shifts down to. You gotta make sure you have room here. Actually, let's get this first. The max and the min. All right, I'm going to put all three: max, middle, and min. You're going from -2 is the middle, right? Because that's a shift down to. So where's your maximum? Now, if you increase by 3, because the amplitude is 3, you hit a maximum of 1. Where's your minimum? -5. You're going 3 above and below the middle. See why I did that first, so we can kind of know how to label the axis? So get on here, just call that -5 at the bottom. 1 is the top here, and put a point here for the middle, call it -2. Draw your axis through -2. If you want to put tick marks, so you actually scale the axis, you can, but you don't have to. Just label the max, min, and middle. Okay, where's the origin? My new origin. You shifted left pi over 4 and down 2. It's right here. Yes? And then just be careful. We're going, it's vertical. I mean, of course it's vertical. I mean, it's up, it's normal. You're going up like normal. So from here, the next mark's at 0, go up to the top. The next mark is at pi over 8, go down to the middle. Next mark, go down to the bottom. Next mark, you go back to the middle. And there's your sine graph that has been stretched vertically by a factor of 3, so the amplitude's 3, then shifted down 2, so the midline's down at -2. Be compressed by a factor of 4, so the period's a fourth of normal, and shifted left pi over 8.